This lesson is about groundwater, and I like to start it by introducing myself and the idea of groundwater. So I might say something like, "Hi, I'm Holly Thomas Hilburn. I'm the director of Arizona Project WET, and my job is to go around the state teaching kids and teachers about water." You would obviously fill in with your own information. And then I say, "This lesson's about groundwater. What do you know about groundwater?" What do you think students might say? Yeah, it's water under the ground. And so we're going to do a few different experiments and work with a few different models to learn what groundwater is. So our first model that we're going to work with is our earth materials tubes. So what do you see in these tubes?
Rocks.
Rocks. We've got some rocks over here. What about this tube? Sand. Yeah. What are some differences between these materials?
Rocks are big.
Rocks are bigger. Okay.
Sand is smaller.
Sand is smaller and tinier. Interesting. So we're going to think about that, and we're going to pour some water into these tubes. In a minute here, I'm going to give Brian this 100 milliliters of water, and he's going to pour it into this tube. But before we pour it in, we need to make some predictions. How many seconds do you think it will take for the water to go through the tube?
Maybe 15?
10.
15, 10 minutes.
20 seconds.
20 seconds. You're going to let the students give a few guesses. And when they do that, then we'll kind of keep that in mind and we'll do an experiment. Now, Brian's job is to pour the water into the tube, but the rest of you have a job as well. And your job is to count how many seconds it takes for the water to go through. So when you see the first drop of water come out the bottom of the tube, you're going to yell stop. But until then, we're going to count seconds. How do we count seconds? 1,000, 2,000. We live in the Colorado River watershed, and so I like to count our seconds with Colorados. So you're going to count 1 Colorado, 2 Colorado, until you see a drop come out the bottom. All right, you ready, Brian?
Yes.
Okay, let's do it. 1 Colorado, 2 Oh, 2 seconds. Maybe even a little less. Thank you, Brian. You can go sit down. So it's important to keep the students involved and give them a chance to engage, but then have them sit down, give them directions. All right, and Lance is going to come up and he's going to do the sand. So you're going to come stand on this side. All right, how many seconds do we think it's going to take for the water to go through the sand?
30 seconds.
30 seconds.
25.
25 seconds.
2 minutes.
2 minutes. So I'm hearing maybe that people think it's going to go through the sand slower. Does anyone think it will go through the sand faster? 4th graders don't always know, so we just let them guess, right? All right, let's go for it, Lance. Are we ready to count?
Yes.
Okay. 1 Colorado, 2 Colorado, 30 Colorado, 31 Colorado. Woo, 31. Who guessed 30 seconds? That was a good guess. All right, once that happens, I want to ask the students, what happened there? Why did it take so much longer for water to go through the sand than through the gravel? And students are going to give a whole variety of answers. Common ones are it absorbed into the sand, it got soaked up, and we really want to get to the idea that it's through the spaces. So I might ask students, well, where did the water go through these rocks? And they'll say it goes through the cracks. Oh yeah, and there's lots of big cracks there, so it goes quickly. When we talk about the sand, I try and get them to see that sand is just really crushed up little rocks, right? So are there spaces between the grains of sand? Yes, there are. And then we can move towards, oh, it's going through the spaces, but it's going through really slowly. And that's important because we want to think about how groundwater moves under the ground. And what is there under the ground? Sand and rocks. All right, and the other thing we want to think about is why did the water go down in the first place? So I often say, what force causes water to go down? Gravity. And if you can't get gravity, you can drop something and say, what made my marker fall? Gravity. And that will help students to get that idea. So the next part of this lesson is about this big groundwater flow model here. And so we start with the question, what's a model? Hopefully students will get to something like a model is a representation of something else that we can't see. And we can't see the groundwater system because it's underground. So when we introduce this model, we want to tell students that it is a model of what it looks like underground. We might ask, how would we know what it looks like underground? Students will come up with ideas like we dig wells and we dig holes and we try and figure out what's under there. And so we're going to say, okay, but we have a model to help us understand what it looks like underground. With the model, we want to help students understand that it is miles across and hundreds of feet deep. And it's a cross section, which means we cut into the earth and we're looking at it from the side, just like you might slice into a piece of cake and see the icing and the filling and the layers of the cake. And so when we look at this, I ask students, what are the parts of the model? What parts of the groundwater system do you see here? Hopefully they'll say things like, I see gravel and I see sand. There are these long skinny tubes and these are wells. Depending on their knowledge level, students might have never heard of a well or they might know a lot about wells. So that's a good thing to know. There's also this impermeable layer that won't let water go through it. So if they ask what that black layer is, you can tell them. And then there's these two big things, which are lakes. So we've got lakes, wells, and layers of earth materials. And the next question we want to ask is, well, how does water get into the ground in the first place? It rains, right? And so you're going to have a volunteer student come on up and they're going to be your rain cloud and they're going to turn the bottle upside down and we're going to imagine rain falling on the mountains where it rains the most and seeping through the cracks and into the layers of gravel and sand. And so here we go, we have water coming into this side here, and I like to point out to students that there are little holes here that let the water go in. And then we're going to ask the question, where is the groundwater? Where is it?
Underground.
It's underground. Where though? Can you point to it?
It's in the layers.
It's in the layers? How do you know it's in the layers? It's kind of hard to see, isn't it? So the groundwater is in the spaces between the sand and gravel in those layers. And that's a really important big idea. So the idea we don't want students to have is that it's in a cave or a river or a lake underground. And so we want them to understand that it's in the spaces. All right, so one way we can help see the groundwater a little bit better is to make it a color. And so we're gonna put some dye in. So come on up, Lance. We're gonna squeeze some dye. We wanna have students use these two wells over here. Pulling it out. And the question we want to ask is, what's happening to that dye?
Spreading.
It's spreading. Is it spreading in all the directions equally? Oh, it's going down. Eventually, we're going to start to see it move this way. So we want to remember, what makes groundwater move?
Gravity.
Gravity, that force that makes water go from a high place to a low place, works underground just as well as it does above ground. So gravity makes groundwater move, and it's between the grains of sand and gravel. Those are two of our big ideas. And our third big idea that we want to get from the groundwater model is, why do we care about it? We care about groundwater because we use it. And so we get to use it through pumping. Pumping is a 3-person job. And so I'm going to have Kirsten and Lance help me out here. And he's going to pump, and Kirsten will hold the tube into the pumping well, which is the one with the well screen, remember? And then Lance is going to go ahead and pump, pump, pump. And as this happens, students will see what's going on. We can see the water moving through the tube, and we want to talk about what we're doing when we're pumping. So who used water today? I brushed my teeth, I flushed my toilet, I took a shower, and that water had to come from somewhere. In many cases in Arizona, it's coming from the ground, and that means when you turn on the faucet in your house, you're going to have groundwater, a groundwater well turning on somewhere in your city and pumping up and delivering water to you through pipes. And we can also see that our green dye is going to start to move towards the well. So that's another way that students can see water moving. So it's helpful to think of the groundwater lesson as 3 models. So you have the earth materials tubes, the big groundwater flow model, and then you're going to have this little small model. You'll have 15 of these, and so that's enough for every 2 students. And you need to have a pump, and you've got your lake, and you've got your water, okay? And so when you set up the lesson, you're going to set these up. They could be in a circle, or they could be in rows. You want them away from the tarp because they have water, and you don't want the tarp to get soaked with water if you can avoid it. So set them up like that, so that each model has what it needs. And now you're moving from the groundwater model, so you're going to say, all right, everybody stand up and find a partner and go sit down at one of the rectangular boxes. Don't touch anything when you get there, just sit down. There'll be a little chaos, and the kids will get partners, and they'll go sit down at those models. This is a nice time if you have 2 people. The other person can go with resetting the other stuff, and one person could be working on this. The other thing for setup for these is it's ideal to have just enough water in the model so that the students can see a little bit of water in the lake. All right. So when students sit down, you're going to tell them again, okay, this is another kind of groundwater model. Again, it's miles across and hundreds of feet deep. But what do we have here? What are the parts of this groundwater system? So one of the first things you want to do is pick up some of this mulch and say, hey, what do you think this represents? And the answer is going to be sand and gravel, just like our other model had. And then you want to talk about this cup. It's really hard for students to understand what this cup is. It is a lake, and they might think it's a well, they might think it's a cup, they might think it's a plant pot, all good answers, but we're going for it's a lake. This is a lake. And then we have a well, just like our other model, we have a well pump and a well casing, and those help us to pump water. And so once we've done that, I like to set up a system where the students are watching me do the thing and then doing it themselves. So I say, I promise you're going to get to do this, but I need you to watch me first. And we're going to start with making it rain. Where does it rain in the model? It rains everywhere. It rains not just in the lake, but in the ground as well. And we make it rain, and we watch our water level. It's important that one student is the rainmaker and one student is the observer, and they're going to observe from both the top and the side. And so they're going to see on the side that the groundwater level has risen, and in the lake that the groundwater level has risen. So you're going to ask that question, who can tell me what happened when it rained in their model? And they're going to answer something like, oh, the water level went up. You want to get them to that idea that the groundwater level rose and the lake water level rose. And that's important because we're getting to the next big idea. Okay, so the way you're going to get to this next big idea is through pumping. So again, why do we care about groundwater? Because we use it, and so they're going to pump. Now, pumping is something we need to give some instructions for again. And so I like to say that pumping is a 2-handed job. You need to hold the straw part of the pump, and then you can pump with this hand. That keeps students from mashing this around and ruining our wells and breaking their pumps. So then they're going to put it in, and they're going to pump into the cup. And as they're pumping, I like to also tell students that they have to pump at least 20 times before they can tell me that their pump is broken, because it takes a little bit to get primed, and you will have extra pumps and you can trade them out and try and keep them running. And we have more in the trailer, so just, give somebody a high sign if you need more pumps. And so students will pump, 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 and then they will see another change in their groundwater model. And so now, as students are pumping, this is a really great opportunity. It's my favorite part of the lesson to walk around and talk with students. You can ask questions like, what's happening in there? And what's going on the side of your model? And what's going on in the lake? And you're going to get answers like, the level is going down. And I like to act a little surprised and be like, but you're not pumping out of your lake, right? And they say, no, but the lake is going down. And why is that happening? And they might say, well, there's holes in that lake, right? Is that like the real world? One of the skills we want students to learn is using models and comparing them to the real world. So is that like the real world? No, lakes don't have holes at the bottom, but what do they have at the bottom? They have rocks and dirt, and can water move through rocks and dirt? Yes, we know that, right? So we're going to help them to kind of think about water in lakes going into the ground, into the aquifer, and then out through the pump into our system, right? And so you're going to kind of walk around and talk with students and have great conversations, and that gives you an opportunity to notice which ones are kind of getting the idea, so that then you can call everyone back. Okay, everybody freeze. Everybody freeze. Somebody help me finish the sentence. When I pump water out of my model. And then call on a couple of students to finish that. You want to get a couple of things. When I pump water out of my model, the groundwater level goes down. And when I pump water out of my model, the lake level goes down. Because that brings us to our next big idea, which is that groundwater and surface water are connected. When the groundwater level goes up, the lake water level goes up. And when the lake water level goes down, the groundwater level goes down. And we have one last big idea for this lesson. So once we have established that groundwater and surface water are connected and they go up and down together, we're going to ask students, what happens on a sunny day to your lake? Hopefully they'll say evaporation, right? Water will evaporate from that lake. And then the question is groundwater a part of the water cycle? Yes, it is. At this point, you can also say, does anybody have an orange bead on their water cycle bracelet if the students have been to that activity? Because that's the groundwater one, right? So you can say, does anyone have an orange bead? And somebody will show you one and you can say, oh, you were in the groundwater system and you were moving through the water cycle. So groundwater is connected to the water cycle. And then this lesson is quite long. Ideally, at this moment, you now have 2 minutes to wrap up, and you're just going to ask a few simple questions so that you get at your 5 big ideas. So the first one is groundwater connected to surface water?
Yes.
And is groundwater part of the water cycle?
Definitely, yes.
How does it move?
Flows between the pores or spaces.
It goes between the pores and spaces, and it moves due to gravity. And finally, why do we care about groundwater? Because we use it. And that's the end of the lesson. So to recap, hopefully you've received by email this document, which is the lesson script. I like to tell people to read this 2 times before breakfast or while they're eating breakfast on the day of the water festival. And then the back page is this Cliff's Notes or cheat sheet, and it really just has how long each thing should take and the key questions you're going to ask. We want to facilitate mostly through questions, and so if you ask students these questions and have discussions about them, you'll get most of the lesson. And so that information is right here. One of the things that we're going to need to reset in between lessons is your sand here. And so what you're going to do is just, you'll have a wet sand bag, kind of stick it under there, and then you're just going to pull this off and let the sand fall out. Kind of dump that out, and then you're going to stretch it back on. So I just do it like that. And then you'll have a little container of sand, and you just pour it back in, you know, more or less up to the line. That's all we need for that. All right, so for your groundwater model, they need to be set up on this side of the table because that's how they drain. You can take this one stand off and that'll tilt it this way so that it can drain a little faster. And then you can put a recharge bottle on to flush the water out. Kids love to pump, and so if you have a lot of dye in the model like we have here, you can just set a couple of kids to pumping and they'll be able to pump that stuff out in no time. So when it's time to reset these, you're going to have to do this while one person is facilitating the other part of the lesson probably for the next group. But you want to just, again, make sure that there's just a little bit of water in the bottom of the model. So the easiest way to do that is to put it on and then tip it to drain a little bit of water out. And once they're drained out so that there's just a little in the bottom, you're going to kind of reset so that the mulch is not inside the lake and you can see just a little bit of water in the lake, and make sure your pump goes back in. And then you'll have to make sure that you have enough water in your pitchers.